Hello guys, good evening. My name is Mukesh Scholar and we are team 6, team Began. Team Began is actually a Nepali word that is the meaning, which has the meaning of science and innovation in English. That we thought could be enough to the name as a team. So our project is about the hydraulic and motorized robot. And these are my teammates, Stake, Tafid, Alyssa, and Laona. In the rest of the slide, my team member will talk about the working and the principal mechanism slides, how it like does it meet any each and every criteria provided by OHA. So that's all we're gonna talk about in the more.
Hi guys, I'm Dave and I'm going to talk about how our HMR works. So it is basically powered by pressure generators, handles and electrical motors and some DC switches which we're going to have in that. The pressurized syringe is going to work on the principles of Pascal's law, which basically states that certain force that's applied to end of a pressurized chamber is just equally distributed, and that we're going to apply in syringe. Also with that, we're going to apply the electrical motors, which just works on the basic principles of Faraday's law. In addition to that, with the help of pressurized handle, we're going to move the arms of the robot, and with the help of electrical motors, we're going to give our robot infinite adjustability. That's how Google says it. So yeah, this is the fusion model of our robot. And we're gonna have some syringe over here and some DC motors over here. We are still thinking about making this part DC motorized so that it can grab stuff, turn it around, move it, and do all the things with it. And it has several applications in the learning, and I believe that even children can play with it and explore several physics with this. To explain more about it, I have Bhavna over here.
Thank you. My name is Bhavna Mata. So the project objective of our model would be basically to explain the hydraulics principle to children. It might be quite complex for like 4th graders, but it would definitely help them understand the transmitting of multiplying of the pressure. Hydraulic arm, like to help the kids understand the force and area relation. And we are trying to make our design. We are trying to meet the universal design criteria. We are putting the syringes that we're using. We are planning to like children could play with it and adjust it accordingly, and there will be some switches which they could use to move the hydraulic arm around and lift some like minor weights. So basically it's just the chance for kids to explore the application of pressure transferring through fluid, and like also give them knowledge about its uses in everyday life without examples. Thank you.
So for the learning outcomes, since the children will have hands-on experience with how the crane functions and also the use of hydraulic brakes, they'll be able to visualize the principle of hydraulics as well as apply the concept of taking smaller components and turning them into bigger ones through the use of hydraulic brakes, such as the fluid pressure turning into friction. And then also they'll be able to obtain general knowledge of how different components work together, such as the syringes and the motors that all work to complete the function of the crane.
So now, as to what quantity we need, what are the things that we need? Like we can see we need the different things like syringes, screws, woods, and all this stuff. The quantities are listed up there. It was good that we work in different departments of YSU, so we have been asking YSU for help, and then at least we got some woods from YSU. We can cut it through what we need for our dimension, and we can also we have also the access of workshop on campus so that we can just get it done. So whenever we have the dimensions, we'll start working on it as soon as possible. For the vendors, we can get many things on the Amazon, and also we can visit the local store like Walmart or the Home Depot for our stuff. But we have already got the motor, right? We have already got the motors and wood, and we are working on the other things and also the switches. So any questions, concerns, comments? Yeah.
How are you going to keep your syringes from being destroyed by these kids? Are you going to have ways to limit where the syringe stops and where it starts? So that they know to pull them out and fluid going everywhere?
That's one thing that we need to think about. We already thought about it.
The syringes that are used in hospital, we are using that, and that is made of hard plastic, and that is quite unbreakable by our 4th grader children. But we're gonna have a pretty good ply as the handle, so that when they're just gonna have this motion for the syringe, and probably we think that's not gonna break. Any other question? Yeah.
So if like a kid were to push on it with like an extreme amount of pressure, like they just would have been slamming it down, like if that pressure would build up and like release the water, how are you gonna like fix that in a way that you have to put more in the syringe? Like it's gonna be an open area that you will be able to like actually add more water to it?
Actually, we don't have to add any water to it, because the whole pipe, that's going to be the exact pipe which is used in hospitals, so that all of the pipe is going to be connected end to end to the both syringes, and because of that there's going to be no water loss. That's what we are hoping, and we're going to seal the end connecting the pipe and the syringe, so we are hoping that will not happen. Any other questions? Yes. I think that's it. Thank you guys.